It is questions like this that make me so glad that I'm an SAT tutor and not a math teacher, because I know that I am right, that my way to solve this for the SAT is the correct way, and that a math teacher is going to tell you a way to solve this that is going to be wrong. We want to do it my way because we want to avoid the most common careless mistake here. So what is my way? Well, look, I've got a crazy equation that has a lot of complicated algebra that I don't want to do because I am lazy and I'm afraid of algebra on the SAT because it is prone to mistakes. So what do? I have answer choices that are numbers. I would love to just test those numbers in the equation. I don't want to have to solve for x. I've got some possible solutions right here. Let's just test them. And this is called guess and check. This is not a crazy new strategy. You've been doing this for a very long time. We're just making sure we revive it for the SAT. You can't use it in school very often, but on the SAT it is a godsend. So how would it work? Well, these are just possible values of x. Plug them in. So if we try -1, actually let's try 5, because I don't want to deal with the negative. Let's warm up with the easier numbers. Let's try 5. So we're going to do x equals 5, and that means my first step is literally just going to be to rewrite everything with 5s in place of x's. Notice I'm not solving anything yet. I'm just rewriting because I don't want to make a careless mistake. And here is where the real benefit is. Some of you are so ingrained in algebra that your instinct is to do something like subtract the 4 to the other side. But we don't need to do that. That's an algebra move. But we've gotten rid of algebra by plugging in for x. So we have all just arithmetic. This is just PEMDAS. So start condensing things, right? So the easiest thing is that 5 and 3 is equal to 8. 2 times 5 is 10. So this is really the square root of 10 plus 6. And that 4 can just hang out there until we need it. We don't need to do anything with it. So the square root of 10 plus 6 is the square root of 16, which is 4. And 4 plus 4 is equal to 8. Boom. 5 is an answer. Meaning any choice that doesn't include 5 is gone. So that only eliminates -1. But I still am going to need to try -1 because some of these answer choices also include it. So we've at least gotten rid of 1, but we now have a clear task for the other choice. So now we're going to try what happens if x is equal to -1. So we do the same thing. We just rewrite it. 2 times -1 plus 6 plus 4 equals -1 plus 3. Okay, so 2 times -1 is -2 plus 6 plus 4 is equal to -1 plus 3 is 2. So -2 plus 6 is 4. The square root of 4 plus 4 is equal to 2. The square root of 4 is 2. 2 plus 4 does not equal 2. This is wrong. That's not valid math. So that tells us that -1 does not work as an answer. So now any choice that includes -1 can go away. And that leaves us with just 5. Okay. So if you like that explanation, you're done. You can just turn this off. You've got it. B is the answer. But look, if you got this wrong because you picked C, you should really understand why and what you need to change about the way you think about this question in order to make sure you don't get it wrong again, because they're going to do this. They like this move, and this is a good example of if you have too much of an algebra brain, you are so stuck in your ways that you can't adapt to these situations where algebra is going to get you in trouble. I know what you did. You took that equation, radical 2x plus 6 plus 4 is equal to x plus 3. And you did a crazy amount of algebra. So you subtracted 4 from both sides. That gets us the square root of 2x plus 6 is equal to x minus 1. Then you probably correctly squared both sides, which would get rid of the square root symbol. So that's 2x plus 6, and that is equal to, well, here's an opportunity for a mistake. It's not going to be x squared plus 1 because we need to FOIL this out. So if you need to, write them both out. It's a foiling situation. So that's going to be x squared minus 2x plus 1. And now we've got another piece of complicated algebra here. We need to bring everything to the right side because we want to have all the x's together so we can factor. That means the other side, the left side, needs to be equal to 0. So we subtract 2x, we subtract 6, And that is going to get us 0 is equal to x squared minus 4x minus 5. Okay, now we got a factor. 0 is equal to, well, what multiplies to negative 5 and adds to negative 4? That's going to be x minus 5, x plus 1. And now we solve. That means that x is going to be 5 and x is going to be negative 1. That's so satisfying. Look at all the awesome algebra we just did. We moved things around. We squared things. We FOILed. We factored. We did all the highlights of algebra. This was like a question that involves everything you did in like 10th grade or 9th grade, right? And we got 2 answers. And those answers are there, right? 5 and negative 1. They're right here. But this is our trap answer. Right? We feel really good about ourselves that we just got those 2 numbers. So we don't think about, well, what other steps are there? Right? When we have x equals a number, our brain is conditioned to think that that's the end of algebra. We've done our job. There's no more steps left. But when we have a radical, we do have an extra step. We have to check for extraneous solutions. Because roots, radicals, are weird things in math, and sometimes they just cause some problems. They create a situation where a number that we get out of our algebra doesn't work in the original expression. That's an issue. We forget sometimes to check for that. Your teacher might remind you, but there's no one to remind you on the test. And so what would be the way to check these 2 answers? Well, we'd have to plug them back in to the original equation. But guess what? That's exactly what guess and check is. We did it already. So here's a clear question where the algebra way is 100% longer. It's twice as long as the guess and check way because we've got to do all the algebra just to get the answers, which we then have to guess and check anyway. Or we could have tried the SAT strategy and guessed and checked from the start, eliminated all the complicated algebra, minimized the chance of losing negatives, foiling wrong, any of that nonsense, and the fact that C is a trap answer never even appears on our radar because we just tried the number and it didn't work. We never had a moment where 5 and negative 1 both looked good. And that's the key. Algebra sometimes points us in this direction where we are so satisfied by what we've done that we ignore the bigger picture math things. And I really don't think most people are going to be able to resist choice C if they do it the algebra way. So please, this is me begging you, don't be stubborn. Don't be a purist about this. There is no extra point on the SAT for doing it the real way. You want the way that's going to get you the points and minimize the chance of a mistake. The guess and check is the best way to do this question without any doubt in my mind. Do it. Put it into your routine. Guess and check when you have simple answers and complex equations.